11.2, the volume of a prism, page 180, 181. Now, the volume of the cross-section of each prism is given in these diagrams. In other words, there's the area of each little bit shown, that's the area of that one. Work out the volume of each prism. Remember to state the units of each answer. Okay, then we can do that. Now, what is a prism? Well, it's hard to define, but if you have a common cross-sectional area that goes the same, that is the same cross-section all the way through, however I decide to cut this little piece of cheese here, this triangular prism, however I choose to cut it, I'll always get a surface area of 22 centimeters squared. So if you just imagine this for a minute, again I'm drawing freehand here. This is a right angle triangle. It joins then goes across. So whichever way I cut it like that, I'll always get one of these, alright? And they'll be exactly the same. That's quite good actually. So I've drawn you three of the same cross-sectional area. And the mathematics is very easy. It's, if I know the area is 22 centimeters squares and it's the same all the way back, to get a volume I just multiply the area at the front, the area of cross-section, by the depth with which it goes into the screen. So for A it's going to be 22 times 8, 822, some account, picking up the calculator, we've got 176, and the units are centimeters cubed because we're doing a volume now. Look, a power of 2 and centimeters to the power of 1 makes centimeters to the power of 3. Again, with this triangular prism here, it's going to go 14.5. Again, whichever way I chop it, I'm going to get lots and lots of, let's try and make it look pretty, shall I? Look a little bit like that. That's not too pretty, I'm going too quick. Anyway, hope you get the idea. So it goes a bit like that. So I'm trying to show you that, again, you get three different versions of the same cross-sectional area. So there you go, that's all, trying to make it look more open and transparent for you. So anyway, the essential ingredients are the cross-sectional area at the front given to us, that's 14.5, multiplied by 10 deep, 145, and we're in centimeters and centimeter squares, altogether centimeter cube. Now this one is a prism based upon a trapezium. This front face is a trapezium there, two parallel lines. That's what defines it as a trapezium from previous videos. So we essentially go 36 times 15, definitely grab your calculator, 36 times 15, we have got a volume of, can't see, 540 centimeter cubes worth of space. I'm not going to try and draw one of these little prisms here, it's just going to be really messy. This one, it's not exactly a cylinder that's lying down, but we don't mind about that because we've been given the cross-sectional area. So I'm just going to go 9.2 times 12 meters deep altogether. Well, I don't know. Grab the machine. 110.4 meters cubed. Is that alright? So that's an introduction. So essentially, what is a volume? If we know the front face of any trapezium, sorry, not just that's trapezium. If we know the front face of any prism and it goes back the same way without getting fatter or thinner, then we merely multiply the area given by the depth or the length that it goes into the screen to get that 3D effect, and that's basically it. That's claiming to be grade C. It's a bit too easy. Question 2 is going to be a little bit more challenging, but only a little bit more challenging really. Now work out the volumes of these triangular prisms. Please learn the name. It's prisms based upon having a triangular face. So that's a triangle gone 3D prism. This is a right angle triangle that's gone 3D prism. This is an upside down right angle triangle that's gone 3 dimensions. So essentially we work out the area of the face and then multiply by 15. Now let's just do A down here. I've got the area of the front face is going to be half times the base times the height. Do you remember that? Let's do it first, which is going to be 4 nines, which are 36. So that's 36 millimeters squared. Now the volume is going to be the area of the front face, all that. It's going to be 36 times 15 deep, and that's going to give us 36 by 15, 540, and it's millimeters cubed. We've gone 3 dimensional. Look, millimeters times millimeters times millimeters, millimeters cubed. This one's going to be centimeters, centimeters, centimeters. The answer is going to be in centimeters cubed. Here goes meters by meters times meters, meters cubed. We'll do them all. Now we'll do B just here. Right, we've got the front face of that triangular prism there. The area is going to be half times the base of 11.2 times the height of 7.4. Grab the machine, so 11.2 times 7.4, then divide by 2. That's why I like to do it. So I've got 41.44, and it's an area, so it's centimeters squared. And the volume is going to be the front area there that I've messed up, which is 41.44. Well, I've shaded, not a complete mess, I've shaded it in for you a little bit. So the volume is going to be this, the surface area there, multiplied by how deep it goes in. So multiply it by 4 times 4, and I've got an error. Let's just do it again. 41.44 times 4. There you go, that's better. I've got 165.76 centimeters cubed. Now I reminded you that that's what it was going to be. And the last one would work up here, I think. So that's C. Now look, I know it's upside down and tricky. If that is a right angle, and it is, then that's the base and that's the height. If you can imagine it flipped over so that the 4 is like sitting along the bottom, just be careful. Base, height. So I've got the area is going to be half times the base times the height. Obviously that's got nothing to do with the height of the triangle. Here is the front face, here's the front face, and that 8 has got nothing to do with that whatsoever. It's 4 and the 6. Right. Half times 4 is 2. 2 6s are 12, and we're in meters squared. It's an area. So the volume is going to be the area of the front multiplied by the depth in which it goes, and that's going to be 96 meters cubed. 12 eighths, 96, and that's that. What I'm going to do is probably pause that little part and then do a second video for 11.2 playing with cylinders and more difficult compound shapes. Alright, so we'll stop there and we'll have a little think about that.